Hi all, I am Anand Sani and my seminar is based on the topic Haptic Technology and Major Haptic Devices. And my seminar is guided by Assistant Professor Anu Jodi, Department of Electronics and Communications Engineering. And next, so this is basically the catalog to my presentation. We'll be going through introduction, history and development, haptic feedback, human haptic perception, a basic haptic system, some haptic devices, haptic interfaces, types, applications, disadvantages and advantages, then conclusion and finally references. So basically, why is it called haptic? So the word meaning of haptic is that it means feeling and understanding the physical or artificial world through touch, and it is derived from a Greek word haptios, which means something which can be touched. And we all know that among the five senses, touch is the only one that is capable of processing both input and output simultaneously. And next, the definition or how haptics can be defined. It is described as the application of touch sensations during engagement with either a physical or virtual environment. So basically, it means when virtual objects are touched, they seem very real and tangible, and the physical interaction can be conducted remotely, referred to as teleoperation, where the interaction with the virtual environment is facilitated through computer-based algorithms and softwares. And there are three different areas of haptic technology. The first one is human haptics, second machine haptics, and the third one is computer haptics. So basically, when an object is touched by an operator, interaction forces are imposed on their skin, and consequently the sensory systems convey information to the brain and haptic perception is generated, and in response to that the brain provides commands that activate the muscles, resulting in hand or arm movements. This principle is basically known as human haptic system. And the second one I have said is the machine haptics, which is defined as the use of machines to replace the human touch autonomously or through telerobotics or any other haptic interfaces. And the third one is the computer haptics. So this actually become more prominent over the years, and it is related to creating and rendering a sense of touch and the feeling of virtual objects to the user with the help of some algorithms and other software architectures. And next, we will be seeing the history of haptics, how haptics have evolved over this time. And to be frank, it is haptics actually originated during the World War II time, and it's between 1939 to 1941. During WWII use, the haptic is used in aeroplanes in order to help the pilots know where their engine was about to start. The haptic feedback system, which would vibrate the control stick, was engaged when the engine neared stalling, enabling pilots to better control their planes. And in 1995, Thomas Massey invented a device known as Phantom, which is actually a medical device which employs computerized arms with thimble-like receptacles at their ends, and this enables the users to insert their fingers, providing a tactile sensation that allows them to feel an object on a computer screen. And in 1996, the Motorola StarTAC was the world's first vibrating phone. The device provided haptic feedback by means of the feature VibraCall, which alerted the users through the now ubiquitous buzz in their pockets. And in 1976, Sega's Motocross arcade game featured haptic feedback in the form of a vibration in their joystick. And in 2015, Apple introduced the iWatch. The watch features a vibrator which feels similar to a tap on the user's wrist to signal notifications and alerts. The screen of the watch also features users post touch, where users can apply different amount of pressure to perform different actions. And in 2016, the sound shed, which is basically a shirt or like a jacket or garment, something which is designed to enable both deaf and hearing audience members to feel the music and air through tactile sensations. And in 2018, a UK company introduced the Tesla suit. They showcased the suit, and it is fully haptic based suit. And in 2021, the Vega startup introduced an haptics, which is actually an haptic gloves. The company's gloves use microfluidic actuators to provide ultra high fidelity haptic feedback. And in 2022, Tesla announced the upcoming release of its Tesla suit. The haptic suit uses electrical muscle simulation to provide users with a physical feedback during virtual reality experience. And the full body suits are available now from July 2023 in 6 different sizes and 2 models. And the burst version is priced at $4,100 and the pro version at $3,700. And next, haptic feedback. So basically there are two types of haptic feedback. The first one is the tactile feedback, also known as cutaneous feedback, and the second one is the kinesthetic feedback, which is known as proprioception. And basically, the tactile feedback, also known as cutaneous feedback, can be defined as the feedback obtained from various mechanoreceptors attached to the outer surface of the user's body, generally on their skin. And the second one is the kinesthetic feedback, which is a different kind of feedback which also plays a significant role in the field of haptics. It can also be described as proprioception, which refers to the awareness of sense of touch created from muscle tensions with the help of sensory receptors. And next, human haptic perception. So basically, the human haptic perception, also known as the active touch perception, is a sense of touch that allows the users to perceive and interact with their physical world. It is a complex sensory system which involves different type of receptors, and basically three, which are mechanoreceptors, thermoreceptors, and nosoreceptors. And the very first one, mechanoreceptors, are the most common type, and they are responsible for detecting physical forces like pressure, vibration, and physical textures. They are basically located in the human skin, muscles, tendons, and joints. And the second one is the thermoreceptors, which are responsible for detecting temperature, as the name suggests. Temperature changes actually, and they are located in the skin and mucous membranes. And the third one is the nociceptors, which are responsible for detecting pain, and they are located in the skin, muscles, and joints. And then some examples on how we use haptic perception in our everyday life are, for example, like when we pick up a cup of coffee, we actually use our haptic perception to feel its temperature and shape. Or else, like when we walk barefoot on a sandy on sands, we use our haptic perception to feel the texture. Or like when we read braille, we use our haptic perception to feel the raised dots on the page. And next, this is actually a basic haptic system, or like how a basic haptic system works. And a basic haptic system composed of two parts, the human part and the machine part. So in the figure here, I have given the human part, which is the left side, and the machine part, which is shown in the right side. The human part actually senses and controls the position of our hand, and the machine part exerts some forces from the hand to simulate contact with virtual object. Also, both the systems will be provided with the compulsory sensors, processors, and other activities. And in the case of human system, the nerve receptors perform the functions like sensing, and other brain performs the processing, and muscles perform the actuation process. And the end effector is a sensitive haptic device. It is various sensors which sense a change in angle, amount of force applied, and gives the information to the computer. and the computer then processes this information and it gives the specific instructions to an actuator. The actuator is actually a device that puts something into an automatic action or like something into a motion. The actuator then applied force to a haptic device which is perceived as feedback force and is felt on the surface of our skin, and this feeling is interrupted by the brain. So this is how a basic cycle of haptics happen. So this is just the explanation of what I have already explained with the figure. And next, haptic devices. So the very first one and the most common, or like we have heard about this Tesla suit actually, and the EMS system or the electrical muscle stimulation system is it uses the electrode to stimulate the user's muscles, creating the sensation of movement and force. And the second one is TENS system, which means transcutaneous electrical nerve stimulation, and it uses electrodes to stimulate the user's nerves, creating the sensation of touch and pressure. And the third one is the motion capture sensors. In the motion capture sensors use inertial measurement units and optical trackers to track the user's movements. And the number of feedback points in Tesla suit are 50, and the haptic feedback range is full body, and the haptic feedback latency is about 10 to 20 milliseconds, and the power consumption is 50 watts, and its price range is almost around $3,700. And the second one is the haptics gloves, which is actually a haptic gloves and the microfluidic actuators. It uses small channels of fluid to create pressure on the user's skin, and the microcontrollers that are used are control the microfluidic activities and process the data from the sensors, and it can be programmed to create a variety of haptic effects. And the sensors measure the user's hand movements and position, and the number of haptic feedback points in haptics gloves are about 100, and its range is not full body but only in hands, and the haptic feedback latency is about 5 to 10 milliseconds. The power consumption is 10 watts, and its price is actually a more costly than Tesla suit. It costs $12,000. And the third one is the Razer Hydra. The haptic feedback motors in this create the sensation of vibration, and the sensors measure the user's hand movements and the position. The data from the sensors is then used to control the haptic feedback to create a more immersive virtual reality experience. And the microcontrollers control the haptic feedback motors and sensors, which can be programmed to create a variety of haptic effects. And the number of feedback points in Razer Hydra are about 1 per controller. The haptic feedback range is not full body like in Tesla. It is also like the same as haptics gloves, that is only in hands. And the haptic feedback latency is about 20 to 25 milliseconds. Power consumption about 3 watts, and it's less costly. It's just $149. And haptic interfaces. So basically the main haptic interfaces are the force based haptic interface, thermal based haptic interface, nerve stimulation based haptic interface, and multi-mode haptic feedback interface, which is actually a combination of all the first three. And the first one, force based haptic interfaces, which is actually the main common feedback format. These interfaces have the capability to replicate both kinesthetic and tactile sensations. And the second one is the temperature based haptic interfaces, and the thermal sensation is of great importance in VR and AR applications, because heat is transferred constantly through the physical contact. Utilizing thermohaptic interfaces, the users can experience a feeling of touching the virtual object with the various thermal properties. And the third one is the nerve stimulation with the haptic interface, which is actually a more promising method to provide effective haptic feedback, also known as electrotactile feedback. By applying conductive electrodes directly on the skin, current flows through this specific body part, especially on hands or like fingerprints, which stimulate the local efferent nerves underlying to produce haptic sensory effect. And the very last one, multimode integrated haptic interface. Different types of haptic feedback have been used in portable and wearable feedback interfaces, where each one has its own advantages and disadvantages. So each method succeeds in reproducing some sort of tactile or like kinesthetic effect. And the types of haptic technologies are like haptics, and it is divided on the basis of usage, then feedback, and then modality. On the basis of usage, there are three types: graspable, touchable, and wearable. Graspable devices, like example is joystick. They're standard haptic technology that generate kinesthetic feedback, and touchable devices is prevalent in consumer applications like in smartphones and all. And the third one is wearable devices, which simulates a sensation of contact by leveraging tactile stimuli, which includes pressure, vibration, forces, and even temperature. And the second classification is based on feedback, and there are five feedback. First one is the force feedback, which is stimulates the human skin, muscles, ligaments. And the second one is vibrotactile feedback, which uses vibrostimulators that apply pressure to the human skin. Third one is electrotactile feedback, that apply electrical impulses that affect the receptors as well as the nerve endings. Fourth one is ultrasonic tactile feedback. It uses ultrasound emitters, which are high frequency sound waves to generate subtle feedback. And the fifth one is thermal feedback. It leverages activated grids in direct contact with the human body. And based on modality, three types. Vibration is standard modality, and the technologies such as eccentric rotating mass and linear resonant activities that have been discussed, uh, that has all been discussed. It is seen in wearables, mobile phones, controllers, and many other haptic devices like in Tesla suit and all. And the second one is kinesthetic. It uses using this modality, it is mounted on the user's body and simulate movement, mass, and shape. And the third one is button. Smart screens lack the familiar tactical feedback of mechanical buttons. Simulated buttons leverage audio and haptic feedback to replicate the sensation of a mechanized pressure pad under the user's finger. And the practical applications of haptic feedback. The first one is the automotive and aviation. The haptic feedback can be directly introduced into different automotives, like in cars, such as in the car components such as steering wheel, seat belt, pedal, seat, dashboard, or driver's clothes. And in aircrafts, the purpose of haptic effect is mostly the same as in the previous case, like in automotives. It provides a pilot with necessary information about the flight control, assisting in the management of the safe and economical flight regime. And next, medicine and dentistry. Medicine is actually one of the important areas. The Phantom is actually one of the important device that is used in medical field. And the MIS, which is the minimally invasive surgery, can leverage this specially crafted automatic laparoscopic tool with a tactile or force feedback to palpate tissues for diagnosing if they are normal or abnormal. Dentists can be educated with the specific VR models using haptic feedback to provide more realistic medical operation feel. And next, computers and mobile devices. And the figure shows how basically a computer haptics work in mobile screen. So it's like when we touch our screen with mobile phones, the data is first sent to a touchscreen controller, and the data is then converted into digital data, and it is then processed by a processor, or there will be like a microcontroller. Then it is given to the driver, and then to the activator, which provides the motion of vibration, and the signal and the output signal will be analog. And next, in gaming and entertainment, like we have known, like there is actually a lot of haptic gloves and haptic controllers, game controllers actually. Almost any new and captivating technology is inevitably tested in gaming and entertainment, as this sphere generates much profit, in fact drives the progress forward. And next, the advantages. Digital world can be experienced and perceived, which is actually the very first advantage, and it is easily accessible and user friendly, and the accuracy and precision is very high. And the disadvantages are it involves complex designs and the high initial cost. And the challenges in haptic technology are, the first one is achieving realistic and natural haptic feedback. So creating realistic haptic feedback that closely mimics the sensations experienced in the real world remains a significant challenge. And the second one is developing high fidelity haptic devices. Current haptic activities have limited resolution and can generate haptic feedback that feels unnatural or artificial. And the third one is the addressing latency issues. Latency between user actions and haptic feedback can be high as 10 to 20 milliseconds, which can significantly impact the realism and immersion of haptic experiences. And the fourth one is minimizing power consumption. Haptic devices can consume significant power, limiting their portability and battery life. For example, the Tesla suit consumes approximately 50 watts of power. And the fifth one is ensuring user comfort and safety. Tailoring haptic feedback to specific use cases and user needs in diverse applications such as healthcare and education requires very careful design and evaluation. And the sixth one is addressing standardization and compatibility issues. And the lack of standardization in haptic interfaces and protocol can limit interoperability between different haptic devices and applications. So basically the conclusion, while haptic technology has been around for decades, the past few years have been a tremendous growth in this sector. The global technology market is estimated to grow at a compounded growth rate of 12% by 2026. So it is not like a video game gimmick. As new advancements and applications become widely available, businesses should explore more ways to implement haptic technology in their operations, like in marketing or like consulting and other consumer experiences. And these are basically some of the papers that I have been referencing so far. The very first one is my base paper, and that's all. Thank you.